Welcome to The Explainer. Today, we are going to talk about something a lot of us know, probably a little too well, heartburn. But what's actually going on in there? And how do all those different medicines, from the simple stuff you grab at the checkout counter to the serious prescriptions, how do they really work? Well, we're going to break down the entire arsenal, from the quick fixes to the heavy hitters. Okay, let's start with that feeling. You know the one. That uncomfortable, rising, burning sensation right in your chest. It's more than just annoying. It's literally the sign of a chemical battle raging inside your stomach and esophagus. So what's really going on with things like GERD or peptic ulcers? Well, at its core, it's actually a pretty simple imbalance. See, your stomach makes this incredibly potent acid to break down food, which is great. But when the body's natural defenses fail, that very same acid can turn against you and start to damage the delicate lining of your esophagus or stomach. All right, so if you've got this acid attack happening, what's the most straightforward way to fight back? Well, the first and, most intuitive strategy is to just neutralize it right then and there. And that brings us to the antacids. The analogy here is perfect. They really are like a chemical fire extinguisher for your stomach. They're not preventing the fire, they're just putting out the flames that are already there. By directly neutralizing the acid, they bring the stomach's pH level up, and that gives you that super fast but temporary relief. But what's really interesting is that not all antacids are created equal. These seemingly simple remedies, they each have their own, let's call it a personality. Take too much sodium bicarbonate, for instance, and you can actually throw your entire body's pH out of balance. Magnesium hydroxide, on the other hand, can cause, well, let's just say it gets things moving by drawing water into your intestines. Then you've got aluminum hydroxide, which can do the opposite and also mess with how other drugs get absorbed. And of course, a lot of them are packed with sodium, which can be a real issue for anyone with heart or liver problems. Okay, so putting out fires is great for immediate relief. But what if we could stop the fire from even starting? Our next strategy is a lot more proactive. Instead of just cleaning up the mess, we're going to tell the body to just make less acid to begin with. And that's where these drugs, the H2 receptor antagonists, or, H2 blockers for short, come in. One of the main signals that tells your stomach to make acid is a chemical called histamine. What these drugs do is pretty clever. They basically get in the way and block the spot where histamine would normally connect. They intercept that "make more acid" message. It really is like turning down the thermostat on your acid furnace. This is a fantastic example of how medicine gets better over time. The very first H2 blocker, a drug called cimetidine, worked, but it had this reputation for causing some weird hormonal side effects and messing with a whole bunch of other medications. But the newer ones, like famotidine, they are way more targeted, so they manage to avoid most of those problems, making them a much safer option. All right, now we're going to bring out the big guns. We're talking about the heavy artillery of acid reduction. These next drugs don't just block a signal, they go right down to the factory floor and shut down the machinery. I'm talking about proton pump inhibitors, or PPIs. So inside your stomach cells, you've got these tiny little machines called proton pumps, and they do the final step of pumping acid out. What PPIs do is they physically latch onto these pumps and shut them down. And I mean permanently. The body literally has to build brand new pumps to get the acid factory running again. And this really gets to the heart of the difference in power, right? The H2 blockers are like turning down the thermostat. The furnace can still kick back on later. But the PPIs, that's like going to the circuit breaker and just flipping the switch, cutting the power to the furnace completely. The effect is way, way more powerful and lasts a lot longer. But you know what they say, with great power comes, well, potential long-term issues. Drastically cutting down stomach acid isn't a small thing. That acid helps us absorb important stuff like iron, calcium, and B12. It also acts as a first line of defense against bad bacteria. So if you lower the acid for a long time, it can make it easier for nasty infections like C. diff to take hold. And there's also a link to a higher risk of bone fractures. Okay, this next point is really important, especially for patient safety. Certain PPIs can block the exact enzyme your liver needs to activate a super common anti-clotting drug called clopidogrel. So what does that mean? It means someone taking both might not be getting the full life-saving protection from their heart medication. It's a serious interaction that doctors have to watch very closely. So far, everything we've talked about is about fighting acid head-on. But there are other kind of clever strategies that take a totally different approach. They're less about fighting and more about defense and, well, evasion.
First up, we have this really cool drug called sucralfate. The best way to think about it is like a smart liquid bandage. The second it gets into the acidic environment of your stomach, it transforms into this thick, sticky paste. And here's the cool part. That paste specifically seeks out and sticks to the raw surface of an ulcer, forming a physical shield so the ulcer can heal underneath, all protected from the acid.
Okay, so that leads to a fun little thought experiment. Let me ask you this. What do you think happens if you take that liquid bandage, sucralfate, and the fire extinguisher and antacid at the exact same time? The answer? They actually interfere with each other. It's kind of a classic case of one treatment getting in the way of another. See, sucralfate needs that acid to turn into its protective sticky gel. If you take an antacid and neutralize the acid first, the sucralfate just can't do its job. All right, our final strategy isn't about acid or bandages. It's all about movement. It's about getting things moving. Drugs like metoclopramide basically speed up how quickly your stomach empties its contents. And the logic here is just brilliantly simple. If you can get the food and acid out of the stomach faster, there's just less stuff in there to splash back up into the esophagus and cause trouble. Okay, so we've looked at all these different ways to tackle stomach acid, neutralizing, blocking, inhibiting, protecting. So what's the big takeaway here? Well, it really boils down to this balance between power and risk and choosing the right tool for the job. And this chart just lays it all out so perfectly. You've got your fire extinguisher and acids for that right now relief. Then there's the thermostat control of the H2 blockers for more proactive approach. Then you have the unplugging the factory power of the PPIs, the strongest option, but with those long-term risks to think about. And finally, the clever liquid bandage protectors that play defense instead of offense. Each one is a totally different tool. So where does that leave us? From a simple antacid to a powerful PPI, every one of these medicines is a totally different level of intervention. The real key here is understanding the difference. Is it a turn down the thermostat kind of day or an unplug the factory kind of situation? Because having that understanding is what empowers you and your doctor to make the smartest, most responsible choices for your health.